So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you so much for the confirmation, everyone. So before we get started, let me quickly introduce myself to you all first so you can be aware of the person you're talking to. So my name is Neeraj Kheria, and I've been working in this IT industry for more than 13 years now, where I have been leading the global design and development teams for designing enterprise solutions for different industry verticals, including insurance, retail, banking, pharmaceutical, aviation, and location-based services. And mostly I have been active in the markets of India, US, Canada, Singapore, Australia, and other Southeast Asian markets so far. And in terms of the training front, I have been working as a corporate trainer as well since last 5 years, where I have been training the workforce of companies including Accenture, Mercedes, EY, Capgemini, Adobe, Credit Suisse, NIT, Grab, among others, in training them on different technologies, specifically in cloud computing, in data science, and in big data engineering technologies. So that's in a nutshell of what I've been doing for more than 13 years now. So the main agenda for this session is we are going to discuss why exactly we need Docker, what exactly Docker is. We are going to look at Docker example, the Docker case study, the Docker components, and then we are going to see a small hands-on on top of Docker technology. So first of all, if we talk about Docker, so Docker is one of the most popular tool that is used for that is used as the main containerization tool available out there in the market. And Docker is and has been gaining popularity, and its usage is spreading like wildfire. The reason for Docker's growing popularity is the extent to which it can be used in any IT company. And there are few tools out there that has the same functionality to find itself useful to both developers and as well as the system administrators. And Docker is one such tool that truly lives up to its promise of build, ship, and run. So here we can use it for building, for shipment, and for running as well. In simple layman terms, we can say Docker is a software that is required for containerization for as a main containerization platform, with meaning that we can build our application, package them along with their dependencies into a container, and then these containers can be easily shipped to run on the other machines. To understand a simple use case, if we look at the problems before Docker, so the idea behind microservice. Now, when we say microservice, that means if we have a main server, for example, let's say if you're talking about any e-commerce stores. Now, that e-commerce store may have multiple components. Suppose we may have a different service for the shopping cart. We may have a different service for adding the catalog. We may have a different service for adding the wish list section. We may have a separate container, a separate service for the payment services, right? So we have different services. So an e-commerce application itself is a main service offered to the client. So when we have the main service divided into multiple microservices, then that can be run separately, and any changes in one service is not going to directly impact the other services. That means suppose if the payment gateway is down, then that is not going to impact the other services altogether. And that's why these are termed as microservices as a part of the solution offering. So the main idea behind microservices is that some type of applications become easier to build and maintain when they are broken down into smaller composable pieces which work together. And each component is developed separately, and the application is then simply the sum of its entire constituent components, as we discussed. So let's say we have online shopping service. We may have service for account, for catalog, for cart server, for order servers, for the payment servers. And for example, the account service is linked to account database. The catalog is linked to the entire list of all the products database. Then we have cart database, and then we have database itself for orders. So for example, here we have seen, imagine an online shop with having separate microservices for user accounts, product catalog, and for order processing and shopping carts. So developing an application requires starting several of the microservices in one machine. So if we are starting 5 of those services, you require 5 VMs on that machine because they all have been deployed separately. So that exactly is what virtual machines for starting the multiple microservices are, and as for the developer's laptop. And an application works in developer's laptop, but not in testing or production. This is due to the difference in computing environment between development, testing, and production. A simple use case. Let's say we have an application here, and the developers they have built the application on top of. Suppose they have a Java application, right? They have worked on Java application, and then they have shared this Java application with the development, with the production team. And since this Java application suppose was developed suppose on Java 8, and this is now being shared to the production team. Now production team tries to run the same application code in their environment. Now they found a bug. The application didn't work because they had a different configuration. Suppose they had Java 7. So now because of the misconfiguration here, now they think, okay, the code, there is some problem with the code. That's why the code is not working. Whereas the developers team think, or the thing, okay, the code is fine without any issues, and then why exactly it is not running in the production environment? And this creates a situation of civil war between developers and the production team. And that exactly is what is solved by Docker and by implementing the entire DevOps cycle as well. So in development, again, there can be software that requires that is upgraded, and in the production, the old version of software might be present that we are going to execute, or we can say compile that piece of code that has been given to us by developers. Now we can run several microservices in the same VM by running various Docker containers for each microservices. That can be solved by using Docker as one of the containerization tool available. So instead of deploying multiple VMs, so obviously we know that VMs, they are bulky. They have a good amount of space and they require a good amount of resources as well to maintain. So instead of deploying 5 different VMs for each and every service, we can use just one VM, and then we can deploy all the services as a microservice that can be bounded, that they can be deployed as a separate container, and then we can bind those containers together by using Docker. So containers are what? Containers are simply, we can say, a complete isolated network that houses the application and all the bins and libraries in order to run it, so that it can be deployed anywhere. It is lightweight to even share as well, that we can use for any particular use case. And then it provides a consistent computing environment throughout the entire whole software development life cycle, where we don't have to worry about having different environments set in different use case. So that exactly is what Docker is as a part of the main containerization tool available out there in the market, right? And that exactly, and again, a small another use case can be, suppose if a Linux-based application which has been written both in Ruby and Python. Now, this application requires a specific version of Linux, Ruby and Python. Now, in order to avoid any version conflicts on the user's end, a Linux Docker container can be created with the required version of Ruby and Python installed along with the application. And now the end users can use the application easily by running this container without worrying about the dependencies or any other version conflicts. And these containers use containerization, which can be considered as an involved version of virtualization. So the same task can also be achieved by using virtual machines. However, it is not very efficient. All right, so let's move further. What exactly is virtualization? So virtualization is basically a technique of importing a guest operating system on top of a host operating system. So this technique was basically used because it allowed developers to run multiple operating systems in a different virtual machines, all running on the same host. For example, we have an application that needs to be executed on different environment, right? Then what we can do, we can simply run the entire application on, for example, we have our own PC, and this PC currently running, suppose it's a Windows, and now we want to deploy some application on top of the Linux environment. So either we can purchase a new Linux server, or we can say a new Linux PC altogether, or we can create a virtual environment where we can set up Linux, and then we can run all the, where we can also associate some of the hardware resources, and then we can run the entire application in this virtual environment that we have created. And that exactly is what virtualization is all about. If we talk about the entire concept for Docker, so before we even discuss Docker, let's discuss the entire concept of containerization. So containerization is a technique of bringing virtualization to the operating system level. And while virtualization brings abstraction to the hardware, containerization brings abstraction to the operating system altogether. The same concept that we have in Java. It is basically useful because again here we don't have any kind of host OS package inside the container altogether, and that makes the entire container lightweight that can be easily shared across any team or any way in that to in any format as possible. All right, so if we talk about Docker, so Docker is one of the most popular containerization platform that packages our application and all its dependencies together in the form of containers to ensure that the application works seamlessly in any environment. So for example, here we have a container. So the container is going to contain the application and all the bins and libraries that's required to deploy the application, and then they are deployed on top of on Docker engine and having the host OS defined. So basically here we can see each application will run on a separate container and they will have their own set of libraries and dependencies. And this also ensures that there is a process level isolation, meaning that each application is independent of other applications, giving developers surety that they can build applications that will not interfere with another. And as a developer, we can build a container which has different applications installed on it and give it to the QA team, who will only need to run the container to replicate the developer's environment. And that exactly is what Docker is. It's a simple tool to design to make it easier to create, deploy, and run applications by using containers. And Docker containers are lightweight alternatives to virtual machines, and it uses the host operating system. And here we don't have to pre-allocate any RAM in the containers like we do in the normal environments. So if we talk about the main difference between virtualization and containerization, then if we talk about that particular use case, as we discussed again, there is a lot of difference between these two. So virtualization and containerization both let us run multiple operating systems inside a single host machine. Whereas virtualization deals with creating many operating systems in a single host machine, containerization, on the other hand, will create multiple containers for every type of application as required. And as we can see here from this image, the major difference is that there are multiple guest operating systems in virtualization, again and again, which are absent in the containers altogether, which are absent in the entire container applications. So here, again, these are the concept for virtualization. And again, as you can see here, the same concept is absent in when we are creating containers out of it. Now, as you can notice here, in terms of advantages for virtualization, so here we can have multiple OS in the same machine, easy maintenance and recovery, and it offers a lower total cost of ownership. If you talk about the disadvantages here, it has multiple VMs, which leads to unstable performance, and hypervisors are not as efficient as the host operating system, and it has a long boot up process, and it's approximately around 1 minute. Whereas if you talk about the containerization, and again the advantages over virtualization, it has containers, it contains the same OS kernel, and they are lightweight and they are smaller. They offer better resource utilization as compared to the VMs, because again the entire resource wastage is the least. And then it has other components. Suppose here we talk about the entire short boot up process as compared to the virtual servers. It has a really short boot up process, almost 1/20th of the second altogether. So first of all, to work with the containers, we had discussed the main advantage for containers over one another, and the benefits of Docker over VMs. Now, VMs they are bulky, they are low, they are really slow on startup, and the entire integration is not easier. Whereas the size is, if VirtualBox is VM, they are elephant, then the containers they are like a mouse. They are really as we can say if a VM's image is for, let's say, 1 to 3 GB, then the entire Docker containers they can be as low as 25 MB in size as well. The entire containers they boot up in 1/20th of of second, and the entire integration is much easier as compared to other platforms. Now, in case of virtual machines, if we have total memory of 16 GB in our system, then we can, now if we are using 6 GB, 4 GB, or we can say 6 GB to different VMs here. From our same hardware, we have created 3 different VMs. That means that now we have allocated 6 GB to this VM, but we are actually consuming just 4 GB. If we allocated 4 GB to this VM and only 3 GB is being consumed, and if we allocate 6 GB to this VM, but only 2 GB is consumed. So you can say only 9 GB of memory is being used and 7 GB is completely wasted. Whereas in containers, we can, in terms of containers, or let's say the Docker, so Docker allocates the memory to different use cases here, and again, only is that specific application which is acquired that is being shared with the application altogether. So that's how the entire application works, and that's how it makes sure that again the applications they are using only the resources that they need, so that the entire wastage of these services can be reduced. So in terms of startups, so if case we have new builds, and again here we have multiple operating systems, separate, they will all have separate libraries, and that's why it makes the entire application much heavier and requires more time to boot up. So in case of Docker, the new builds are based on same OS and they have separate libraries, and that's why they are lightweight. They are based on same OS, and that's why it takes almost 1/20th of a second in order to boot up any specific container. That's how fast they are. And in terms of integration, so integration in virtual machines is possible, but it is costly due to the entire infrastructure requirements and it is not easily scalable. Whereas if we talk about Jenkins Puppet, again, here we have Jenkins being one of the most popular tool for continuous integration. Then here we have Puppet, and here we have Ansible and Nagios, which are basically used for the configuration management system. And then we have Selenium and Git, which are basically used for the continuous deployment here. And the integration in Docker is faster, cheap, and easily scalable as compared to other platforms. That exactly is the main purpose of using this entire container-based application. Now, in terms of Docker example, now we have, again, we can create a complex requirements for a microservices are written easily to write in a Docker file. So for creating containers, we use something called as Docker file, and using Docker file, we can create the image, and then using that image, we can create the containers out of it. So we simply push the Docker files to the GitHub repository, which is like a remote repository that we can allow the developers to push their codes here directly. And then when this code is available, then Jenkins server being the continuous integration platform, it is going to pull this code directly from the repository, and then it is going to create a build out of it. And this build can be pushed to testing, staging, or the production servers. This can be done accordingly. And the CI server pulls it down and builds the exact environment that will be used in production to run the test suite without needing to configure the CI server at all. And there we can deploy it out on a staging environment for the testers. And here we can roll exactly what we have in development, testing, and staging into the production environment that we were working on. So in order to understand how industries work together, we can work on different problem statements. Like we can create a custom script where we can create the entire VM. So the environment was optimized for the legacy Java-based applications, and their growing environment involves new products that aren't solely based on Java. And in order to give the students again the best user experience, the university needed a modernized approach to their current to the current application. And the university wanted to improve the way they architect applications by moving to a microservice-based architecture for the applications. So there they define the entire UI, business logic, and data access layers. And this was their monolithic architecture. And now what they did, they simply divided the entire UI into multiple microservices. And then they link with this separately with the database. And that exactly is what they have achieved by using a microservice architecture. So let's just look at Docker components first before we move on to the hands-on. So Docker Hub is basically just like we have GitHub repository. It is a cloud, it is basically a cloud hosted service that has various Docker images. Now we can create our own Docker image and upload on Docker Hub, or we can also download the images from Docker Hub. So here we can also integrate the same application at multiple points. We can do that. Next, we have Docker images and containers. So Docker images, again, these are read-only templates used to create containers, which are built by Docker users. And these are stored in Docker Hub in a local registry as we all are aware about. And these are stored in Docker Hub or in a local registry. And we can use this when we are trying to run Docker-based containers. So basically they are isolated application platforms which contains everything that we need in order to run the application. And here we can build it from one or more images. We can simply do that. That exactly is what we are going to do as a part of the hands-on as well. So let's see how we can install Docker as a part of our hands-on. Now for deploying Docker, we are going to need a server. So for using a server, we can use any platform or we can use a server which already we have deployed. So currently we are going to use a simple AWS platform in order to deploy a server. Now this is basically we are deploying a virtual server on which we are going to install the entire Docker service, and then we are going to get started. So if you're not aware about AWS platform, not to worry about that. Here we are simply creating a virtual server that we are going to use for getting the access to the container that we are going to create here. So here, let's add the storage, let's add a tag, let's configure the security group. Let's say we want to give the access to port 80 as well. Here we can click on launch. We can download the key pair, click on launch instance. Now we can wait for a couple of minutes for this instance to be deployed here. We can, in the meantime, we can name it as Docker as a good practice while we are deploying the applications. Here we can copy the IP that we are going to use in order to get connected. And for getting connected, we can use any of the SSH client like we have Putty when we are working with Windows, or we can make use of other application like we have MobileStorm. So this is much feasible and much easier to get connected as we don't need to have any kind of, or we don't need to convert here PEM keys into .ppk file in order to get connected. We can simply enter the host IP, we can specify the username, and then we can specify the key that we have used while we had deployed this entire instance. This instance creation, it takes a bit of time, so we may have to wait for a couple of minutes. So still it is currently being initialized. So in the meantime, let's see if we are able to get connected. So as you can see, now we have got connected to this entire server. Now we can start with installation of Docker. So first of all, we can clear the screen. We can resync all the services by using apt, and here we can use update for resyncing all the services altogether. We have sudo for giving the admin privileges, and then we have apt-get, and then we have update. So basically, before we start with installation for any packages, it's always advisable to resync all the services before we can get started. Now, here we are going. Now, there are certain packages we require in a system before we can work with before we can proceed with installation of Docker. So basically, here we are going to execute certain commands that are going to get these packages installed on us. So here we have apt-get install. By using the curl package manager, we are going to use the apt transport, and that with the HTTPS CA certificates. So here we have CA certificates. Software properties, that's called the common software properties that we are going to use while we are setting this up. So basically this is going to install the entire package that we are going to need. And then we are going to set up the Docker repository. Now we are going to import Docker's official GPG key to verify the package's signature before we can install them with the apt-get. And for that, we have to simply use the curl package manager. So here we are going to use curl, and then we can define the parameter for FSSL, and here we can define the actual link, that is HTTPS, and here we are going to refer to the official image as download.docker.com/linux/ubuntu, as we are currently working on Ubuntu, and then for the entire GPG package. And then we are going to execute another statement as sudo apt key add. So here we can define sudo apt key that we are going to add, which is going to verify package signatures before we can install them with the apt-get package. That is what we are currently doing here. All right, so now we are going to add the Docker repository in our Ubuntu system, which contains Docker packages, including all its dependencies. So for doing that, first of all, we have to run this entire statement from where we are going to install the entire package that we want to run. So as you can see now, the package has been executed. Now there was a simple typos as HPG is going to be GPG altogether. Now, so here we are going to use sudo apt-get repository, and there we are going to define the entire. Therefore, again, here we can define the default parameter to be arc, and here we're going to define this as AMD64. And then we can define the actual package path. So here we have https download.docker.com/linux/ubuntu, and there we can define the default release as lsb release cs. That means again the c that we are going to install the cs, and that is for the stable version that we have. So here we can define stable. So basically this is going to add the Docker repository on a system which contains Docker packages, including all of its dependencies that we can execute with the current statement. Here we can define the, now here once we define the entire add as repository, now we are ready to add the Docker package into the entire container here. So let's get started. Now here we can ring all the services now. So here we have sudo apt-get update. Let's resync all the services, and then we can use sudo apt-get install docker ce. Now there are two different variations that we can install here. We have docker.c or we have docker.io. We can use both the packages. Let's wait for the entire packages to be configured. Once we are done, then we can start by working on different command sets that we have in Docker. We can play around with the entire Docker tool. We can get started with creating all the images as well. We can create the Docker file. We can, by using the Docker file, we can create the images, and then by using those images, we can deploy the image, and then we can have it deployed one by one. So basically we have now here we can create the multiple containers which are already available here. So for example, if you want to search for multiple applications, right, then we can create the multiple applications as well, or we can use multiple images of which are already available in the Docker Hub repository. For example, suppose if you have to search with on multiple applications, or we can say multiple predefined images, then what we can do here, we can search for Docker. And suppose here we have search. So for example, here we want to search from the entire application images which are available as Docker hello. So we can search for Docker search. And now it is going to search for all the available element, okay, all the images which are currently available when we are going to work with Docker element here as a part of the setup defined. So as you can see here, these all are the default packages available by Docker itself. Now these all packages that we can see here, which says, okay, these all are the official packages. That means there is no harm in working with these official packages. We can deploy it at any point of time we want. So currently we can see, now we can search for the entire hello statement here. And again, if the images are official, then again here we can see the official image defined as okay. That means now if we are looking to pull any specific image, then we can define the image name, and then we can simply pull it, and then we can deploy the same image as a part of the container-based application that as and when required. In order to pull this entire official image for Hello World, which is simply a Hello World application which has been deployed on Docker. So for doing that, what we can do here, we can simply use a statement as Docker pull Hello World. So basically using Docker pull, we are going to pull the official image which has been made available by Docker. And then we didn't add the sudo statement because again, currently we have added the entire command for the root user. So here we have to include Docker. So currently using the default tag as latest, currently it is pulling the items from the official repository as you can see here. So now the official image has been pulled from Docker repository itself. And now if we want to start the containers for it, as you can see, the pull has been completed, right? So now if we want to run the application, then here we can simply define Docker run, and then we can define the image out of which the entire container has been created. That is Docker run hello world. We can add sudo as to give the admin privileges. And as you can see here, this entire message has been displayed. That means the entire container had been successfully created and it has been successfully deployed as well. And now if you want to run Jenkins here, we can simply use Docker Here we can use sudo docker run Jenkins as the image that we are currently pulled. So when we are running Jenkins here, we have to make sure that in the entire plugins, all the parameters are completely defined, and then only it is going to be executed. As you can see here, we have to edit. Now here we have to look for the initial admin password. Once we enter that, then again this is going to be executed. So let's say we wrap it up for today. And again, thank you so much for being a part of the session. Have a great day ahead. Take care. Bye bye.